Number 3, determine the rate at which the water level rises in an open container if the water coming is through a 0.1 meter square pipe has a velocity of 0.5 meter per second and the flowing rate going out is 0.2 meter cube per second. The container has a circular cross section with a diameter of 0.5 meter. So in this situation, so it is very simple. You could imagine it straightforward. So we have an inlet here and then we have an outlet here. So if the inlet is slow but the outlet is very fast, so means that the water level here will going down because the water supply is not enough, so means that there is the water from the tank need to be flow out. So this is the idea of flow in must be equal to the flow out. So but in other situation, if the flow rate is very high but the inlet here is very high but the flow rate at the outlet here is very low, so the amount of fluid inside the tank will increase. So this is the situation. So the basic idea that you could do this is without Reynolds transfer theorem idea, you just calculate what is the volume flow rate for inlet and what is the volume flow rate at the outlet. If the value is equal, so means that there are no increment inside the tank. So but if the inlet here is higher, so compared to the outlet here, so means that the water level will increase inside this inside the tank. So we draw the control volume. So this is our control volume. So we have the velocity here, and then this is the n vector for the inlet. So this is the velocity to the right, and the n vector here is also to the right. So and then we take the possibility of this surface, which is this is the vector n, which must be outside the control volume, and we could write the velocity of the surface here increase with dh dt. So dh dt means h here is the vertical height. So the water surface here is moving from here to here, for example. So mean it's moving from h1 to h2 at certain time. So we could say that the speed here is actually dh dt. So and then we write down the Reynolds transfer theorem. So we have dn over dt, and it is equal to 0 actually here. So and then we have d dt integration rho d volume plus integration rho vn dA. So the here we cannot simply it is equal to 0. Why? Because the density is fixed, but the volume here may be changed. As we know that if the water level is increased, so for sure the velocity, the volume is increased. So if the volume increase, so dv d volume over dt. So we get this dt from here. So d volume over dt has some value, so it is not equal to 0. So and then we could calculate the effect what happened on the surface. So in this situation, we have 1, 2 and 3 surface here. So this surface, okay, this idea is put in this equation, and this surface is only for this one and this one. So this is the Reynolds transfer theorem equation. So we dn dt is equal to 0. It is the conservation of mass. So and then we substitute all the parameter for the first term. So we could get that the rho is equal to rho, and the volume here is the cross-sectional area of the tank. So we have a tank here. So the cross-sectional of the tank, and then we multiply with h, means the height of the water. So and then for this one, so we need to calculate the effect of the cross-sectional area at inlet here and the cross-sectional area at the outlet. So in the inlet, we know that the velocity v1 is in opposite direction with vector n. Here the velocity is at the same direction, so means that we need to put a negative sign for this velocity. So and then the velocity for the outlet is remain in positive sign. So and then we could write all these parameter. So and then we could solve it, because in this question we need to calculate what is the dH dt. So if we solve this equation, we found that dH dt is equal negative 0.763 at 4 meter per second. So the negative one means the water level is going down. So according to this situation, the flow rate at outlet is bigger compared to the flow rate at the inlet. That's why the water in the tank decrease.